Here's how to create this effect using Blender 3D. We will make use of a paid Blender add-on called Flip Fluids for the second phase. Feel free to check out the first link in the description to download the project files. Hi, I'm Rajmeet from In The Code, and let's get started with today's video. I start by deleting everything in the scene, add a reference image of the jar, Alt-G to reset its location in the 3D viewport. Shift-A, add a mesh circle. From here, it's a matter of pressing E to extrude and S to scale the extrusion up or down to match the contour of our reference jar image. Select the bottom vertex loop F to fill a face. Select the top vertex loop E to extrude up, and we use this part to make the lip of the jar. Control R, add a loop cut in the middle. In the operator panel, we make the number of cuts to 6. Now in face select mode, holding down Shift and Alt, we select alternate face loops. Alt E to extrude faces along normals to give us that indent at the top. In object mode, set shade smooth on the mesh. Control +2 to give 2 levels of subdivision modifier. In order for the glass shader to work properly, we need to give the mesh some thickness inside. For this, I add the solidify modifier and decrease the thickness until we move slightly inside. In order to model the cap of the jar, we start with a mesh circle. Adjust the size so it fits outside the mouth of the jar. Extrude in Z by 0.1, extrude and right click to leave it in place. Now scale this in by 0.9. Again extrude Z 0.1, extrude, right click, leave in place. Scale out by 0.1. Extrude Z 0.4, F to fill the top face. Select the bottom vertex loop, E, right click to leave in place. Scale 0.9 to bring it inside. Control 2 for 2 levels of subdivision modifier. Select top face and insert inside to retain the shape better. Same with the bottom face. In the center, add 2 loop cuts. Right click to leave them in place. Select the face loop, Alt E to extrude faces along normals. In order to make the ridges at the top, I divide the top section in 2 by adding a loop cut in the center. Selecting the top half, you press P, separate by selection, so this is a separate mesh now. The reason I'm doing this is to avoid heavy density geometry on one part of the mesh and lower density on another part. This leads to shading issues. On this top mesh, apply subdivision modifier to get more geometry to work with. A to select everything, right click to subdivide one more time for even more geometry. Now with edge select, selecting a horizontal loop, we go select, check or deselect. Now holding down Shift and Alt, select an edge loop that is perpendicular to this one. Select loops, edge rings. From here, Alt E to extrude faces along normals and take it inside this time. Shade smooth and Control 2 to add subdivision. Parent this mesh to the original cap mesh. Selecting the top faces of the jar mesh and reducing its size so it fits within the cap mesh. Render setup. I add a camera and set up the viewport for camera view. Add a plane mesh for the backdrop. Make the world lighting to 0 and start adding lights in the scene from scratch. Add an area light, bring it above the jar. Increase power to make it bright and scale it to make it softer. Extend the back side of the plane. We delete the principal BSDF and add a glass BSDF instead. Plug it into the surface socket of material output. The look of this shader will change depending on the thickness value in the solidify modifier. I add a transparent BSDF and mix it with the glass BSDF. For the factor of the mix shader, I use the facing value in the layer weight node. When viewing the layer weight value into the surface, the parts which are black will use the second shader, that is transparent, and the parts which are white will have glass BSDF, so that we get that transparent look in the center of the jar. The cap material is a principal BSDF with metallic at 1 roughness reduced. Now here it looks black because everything around in our world is black, so that's what it is reflecting. We fix it by giving a color to the backdrop and covering it from all sides so that we don't have the black void seen from anywhere. I get this beautiful strawberry model from the paid plugin called BlenderKit and place it above the jar. We select the jar, go to the physics panel and select rigid body. This will be passive and the shape will be mesh because we want the falling strawberries to interact with the inside of the jar. Select the jar, rigid body active, shape can stay as convex hull. Scene properties, enable rigid body world, enable split impulse and put both these values to 20. Go to the start of the timeline and press play. The strawberry falls into the jar and interacts with it like it should. Now I linked duplicate the strawberry by pressing Alt D and keep moving it straight up in the Z direction. We do a linked duplicate instead of a direct duplicate so that we are using the same mesh data but having separate objects. Now if I press play, the strawberries fall into the jar, interacting with the jar and with each other. We make the backdrop as passive rigid body with shape as mesh, so the spilling over strawberries fall naturally on it and rest there. Now on baking the mesh, this is the kind of effect we see. Select all the strawberry meshes, export Alembic. Check selection only and disable hair and particles. Now we disable the original collection and import the Alembic cache version. Each of these strawberries now is not running through rigid body simulation, but through a transform cache object constraint. We add the strawberry material to one of these. Shift plus G to select the collection. Control L, link materials. For the liquid, we disable modifiers on the jar. From the bottom face, press Ctrl++ to increase selection until where we want the height of the jam liquid to fill. Duplicate this mesh, right click to leave in place, P to separate by selection. Remove the jar material from this mesh. We delete modifiers from this as well. After enabling modifiers on the jar, adjust the scale of jam mesh so that it sits inside the jar. Select top vertex loop F to fill in face. We choose this jam mesh as obstacle since this is what gets filled up. Add a cube, set its visibility to bounds, and transform it such that it fits right where the simulation will happen. This is our domain. Add a cube as the inflow object. This object will fill the jam liquid into our domain. Subdivide this mesh to get more geometry to work with. In X-ray mode, select top vertices and assign them to a new vertex group. Name it Displace. Add a Displace modifier onto the inflow mesh. Select texture to be clouds. Make the size smaller. And pick the vertex group. In order to animate this, we add an empty to the scene. Animate this empty up in the Z continuously by giving it a hashtag frame driver in Z location. Now dividing this expression by 50 will make it go up slower. In the Displace modifier, change the coordinates from local to object and select the empty. Now when we play the timeline, we get continuous wave-like motion at the top of the inflow mesh. We can divide the frame by 25 to make it move twice as fast. In Flip Fluids, this mesh gets assigned as inflow. Now we shall check the animation of the cached strawberries to predict when the jam liquid should start filling up the domain from bottom to top. On the inflow object, add keyframes to location and space them out accordingly. In jam obstacle, we need to enable inverse. Enable auto load baked frames in the add-on settings. For the domain cube, go to the surface tab. Inside meshing volume, select object volume and pick jam obstacle. So we tell the add-on that this mesh needs to be filled up. Since the inflow object is being animated, we need to check the export animated mesh checkbox for it. In the domain, let's set a custom location for the cache on our drive. This avoids weird issues where the simulation doesn't work at all. Enabling viscosity and surface tension at their default values works in this case because jam is a thick liquid. Now with the starting test resolution of 65 and frames at 170, let's give the simulation a bake. The way the add-on works is first the animated data is exported, then the simulation is baked. This is how our crude effect looks like. Flip Fluids has this beautiful button called Organize Outliner, which automatically cleans up the mess that is being created in the outliner into separate, neat collections. As a next step, I want the strawberries falling to interact with the filling jam. This will create some natural splashes and inconsistencies to sell the effect we're going for a little better. One thing is the strawberry mesh is very dense, so I'm going to run the decimate modifier on each of these to bring down the polygon count on these. This will mean less computation for Flip Fluids when it makes them interact with the filling jar, and hence less chances of Blender crashing on us. Now for all of these strawberries, I need to assign a Flip Fluid obstacle with export animated mesh data checked. I also need to adjust the timing of the inflow objects reaching to the top so it feels more natural. There are some strawberries that are peeking outside of the jam, so we adjust the size of the jam obstacle to encompass every strawberry inside and rebake. This video has been sped up, but it took a considerable amount of time to bake this because of all the interactions between the berries and the filling liquid mesh. As a final step, I also add obstacle to the remaining strawberries and rebake. For the jam material, we can use a Principled BSDF color picked from the strawberry red. Increase transmission, add a translucent BSDF and mix it with the Principled. For mixing factor, we again use the facing from the layer weight node. I add a color ramp and flip the black and white sliders to see if we can get an interesting look that way. To add even more detail, we add a noise texture plugged into bump height that feeds into the normal of Principled BSDF. This gives a very extreme effect, so to make it subtle, we decrease the strength to about 0.4, play with the IOR value to get something that looks visually appealing. To make the jam color a little bright, I use the hue saturation value node and plug that into the base color of Principled BSDF. This allows me to tweak the color more precisely to my liking. Finally, we give some basic transform animation to the lid of the jar so it closes once the jam has been filled. I add a little bevel on the backdrop wall right behind the jar and hit render.